So what is a one-to-one correspondence? All right. If the elements of sets P and S can be paired so that for each element of P, there's exactly one element of S and vice versa, then P and S are in what's called a one-to-one correspondence. So if you look at the picture that I've got drawn here, we have 3 dogs and we have 3 houses. There is 1 dog for every house. Like this dog could go to this house, second dog could go to the second house, third dog could go to the third house, and it's literally like this perfect pairing up. It's called a one-to-one correspondence. And that's actually an easy way to explain it to kids, is just by using your hands, right? If your 5 fingers on your left hand match up with your 5 fingers on your right hand, that would be considered a one-to-one correspondence. There's 1 finger for each hand to pair up with. Now, what if the first dog decides to go to the second house or the third house? What if the dogs change houses? It's still a one-to-one correspondence, but let's find out how many one-to-one correspondences there would be between 3 dogs and 3 houses. So instead of doing that exact example, we're going to do one similar. We're going to let set A be Bob, Jane, and Mary, and set B is going to be first place, second place, third place. So maybe they're competing in some sort of a competition, and there's 3 prizes, first place, second place, third place, and there's 3 people. So those match up. That's a one-to-one correspondence. I'm going to abbreviate them, Bob, Jane, and Mary, just to make things easy. And it says, how many one-to-one correspondences are there? So we know there's 3 people in 3 places, but let's list out all the different ways they could land in these 3 places. So I'm going to set up first place, second place, and then third place, kind of like a table here. And let's talk about the order. Well, to start with, let's say that Bob gets first place. So if Bob gets first, then maybe Jane gets second and Mary gets third. Or if Bob gets first, Jane and Mary could switch. So those would be all the combinations where Bob got first place. Let's put Jane in first place. If Jane gets first place, maybe it goes Bob, then Mary. Or maybe Bob and Mary are switched. So maybe it looks like that. So there's another way that they could get first, second, third place. So that's all the ones where Jane is first. Let's do where Mary gets first place. If Mary gets first place, then it could be Bob or Jane. Or again, maybe Bob and Jane could switch. And that's all the different combinations where Mary would be first. So if we go through and count, 4, 5, there are 6. There's 3 people. There was 3 places. And it turns out that there are 6 one-to-one correspondences. Another way we shorthand one-to-one is we literally write one-to-one like that. 1-1. That's a way you can abbreviate it. So how could we come up with the 6 quicker? Because we don't want to have to actually write it out every time. And what if it was 4 people in 4 places or 5 people in 5 places? It would take a really long time to write these out. So it actually turns out as a shortcut, the number of one-to-one correspondences between 2 sets with n elements is n factorial. So the exclamation point in math is called factorial. And what it means is you just keep multiplying down until you get to 1. So 2 factorial would be 2 times 1, which is 2. 3 factorial is 3 times 2 times 1. That's 6. 4 factorial is 4 times 3 times 2 times 1. You see how it tapers off till you get to 1? And if you multiply that on a calculator or in your head, you get 24. 5 factorial would be 5 times 4 times 3 times 2 times 1. That would equal 120. So that's a faster way to figure it out. So it says if you have n elements, well, we had 3 elements up here, 3 people going to 3 places. So if we look at this, that's how we got the 6. Do you see that? This is 6. We could have just done 3 times 2 times 1. And the reason why it works, if this is first place, second place, and third place, how many choices do we have for who gets first place? Well, we have 3. It's either Bob, Jane, or Mary. After someone is assigned first place, there's only 2 people that could fit in second place. And then once you choose a person for second place, there's only 1 person left to go in that last slot. And that is exactly what 3 factorial is. and that's what 6 is. So if you get a question in the homework that asks you how many one-to-one correspondences are there, if there's 4 elements, it's just 4 factorial. It'd be 24. Or if there was 10 elements, it would be 10 factorial, and you could just do that on a calculator, right? It's going to be a really large number. But this is the shortcut way that you find out the number of one-to-one correspondences.